Okay, so on to part 2 of the video. Directions for the next example ask us to find all solutions of the given equation on the half closed interval from 0 to 2 pi. So again, going back to what we learned in the previous lesson, this is asking us to find the particular solutions. Okay, not the general solutions, but we want to find all of the given solutions on that particular interval. And we're given the sign of x plus pi over 4 plus the sign of x minus pi over 4 is equal to -1. So for us to be able to solve here, we're going to have to use the sum formula for that first sign expression and the difference formula for the second one. So when we use the sum formula, it's going to be the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Okay, plus, and then we're going to use the difference formula for that second sine expression. So that's going to be the sine of the first times the cosine of the second. And we keep the sign the same, so that's going to be minus the cosine of the first times the sine of the second. Okay, so when we look at this expression here, these two quantities, this one and this one, are the same. One's positive and one's negative, so they're going to cancel one another out. And then these two expressions here are the same as well. So that means that we have, when I add those two together, we have 2 sine of x's times the cosine of pi over 4 is equal to -1. Well, we know that the cosine of pi over 4 is rad 2 over 2. So this factor of 2 on bottom will cancel with that factor of 2 on top. And then we can divide both sides by rad 2, which makes the sine of x equal to -1 over rad 2, which rationalizes to negative rad 2 over 2. So we want to find where sine is rad 2 over 2. That makes our reference angle here pi over 4. And we know that sine is negative in quadrants 3 and 4. So the angles in quadrants 3 and 4 with reference angle pi over 4 are 5 pi over 4 and 7 pi over 4. So those are our two particular solutions on the half closed interval from 0 to 2 pi. Okay, so 2 more examples to close out where directions ask us to evaluate the expression. I want to see you guys give this one a try, so go ahead and pause the video and then start it up once you've worked it through. Okay, if I were willing to bet, I would guess that most of you work this one through using the sum formula for cosine, and that's fine. There's nothing wrong with that. But I actually think we can work this through in a more timely fashion. So let's do it the quicker way. Inverse sine of -1. We want to find the inverse sine of -1. We want to think to ourselves, the sine of what angle between negative pi over 2 and pi over 2 is -1? And that's negative pi over 2. Plus, we want to find the inverse cosine of 0. Again, that's going to be equal to some angle measure. We want to think to ourselves, the cosine of what angle between 0 and pi is going to be 0, and that's pi over 2. So we can add those two angles up. Negative pi over 2 plus pi over 2 is 0. Cosine of 0 is 1. Could you have used the sum formula? Yes. Would it have made the work more complicated? Yes. You still should have come up with the same answer. But I think this is the more efficient way to work the problem through. Okay, let's try another one of these. So we have the cosine of the arctangent of 1 plus the arccosine of x. All right, we'll work this one through. I'll work this one out for you. So cosine of the arctangent of 1, first off, we want to figure out what the arctangent of 1 is. And we can figure out what that is. So we want to think to ourselves, the tangent of what angle between negative pi over 2 and pi over 2 is 1. And that angle is going to be pi over 4. So I can actually rewrite this as the cosine of pi over 4 plus the arc cosine of x. And then I'm going to use the sum formula to rewrite that expression. So that's going to be the cosine of the first times the cosine of the second and then we take the opposite of the sign, which is going to be minus the sine of the first times the sine of the second. Okay, now for both arc cosines of x, we know that that's going to be equal to, like, it's going to output some angle theta. So we're going to go ahead and set that expression equal to theta. And if the arc cosine of x is equal to theta, then we can rewrite that expression in terms of cosine. We can say that the cosine of theta has to be equal to x. Well, what we can do then is we can draw a diagram modeling that circumstance. Okay, so there's our right triangle. There's our angle theta. We want the cosine of angle theta to be equal to x. So cosine is the ratio of the side adjacent over the hypotenuse. And if the side adjacent is x and the hypotenuse is 1, adjacent over hypotenuse, x divided by 1 is going to be x. So what we can now do is use the Pythagorean theorem to find the missing side length. And that missing side length when you use the Pythagorean theorem is going to be 1 minus x squared. So essentially, like, what this is asking us to find is asking us to find the cosine of pi over 4 times the cosine of, we can replace the arc cosine of x, since that's going to be equal to some angle measure theta. I'm going to replace that expression with theta minus the sine of, sine of pi over 4. And then again, we're going to replace the arc cosine of x. The output for that is going to be some angle theta. So all we need to do then is we need to come up with expressions for both the cosine of angle theta and the sine of angle theta based on the diagram that we have over here. Okay, so we know that cosine of pi over 4 is rad 2 over 2. The cosine of angle theta, we know that that's adjacent over hypotenuse, which is x, minus the sine of pi over 4, which is rad 2 over 2, times the sine of angle theta. So if we look over here to the diagram, angle theta, sine is going to be opposite over hypotenuse. So that's rad 1 minus x squared all over 1, which is rad 1 minus x squared. And then the only thing left for me to do, like, to simplify this, I can, like, factor a rad 2 over 2 out, and that leaves me with x minus rad 1 minus x squared. Okay, so we'll definitely see more examples like these last two and more difficult examples like these last two in the next lesson that we're going to look at in section 10-5. So that wraps up your sum and difference formulas, and then we'll take a look at the double angle formulas, half angle formulas, power reducing formulas. There's a bunch of new formulas to look at in the next lesson. Okay, we'll see you guys soon. Take care.